Alright, so we are on chapter 2, specifically talking about scientific notation. So you might ask yourself, what is scientific notation? Well, a lot of times in science you're going to find that they work with numbers that look like they're massive. So there is something called Avogadro's number in science, which is 6.02 times 10 to the 23rd. 6.02, 2 times 10 to the 23rd power. I wasn't supposed to be black, so that's boring colors. But you can tell in here that, so basically this is talking about atoms. Atoms are really, really small, right? And so when you're trying to think about how small atoms are, sometimes you're going to be using numbers that are so big that if I could say 6 million, billion, trillion, gazillion, billion, frankillion, it's an actual number, I didn't just make it up. Nope, it's real. I could say numbers actually that big, right? But those numbers are kind of hard to comprehend. So what they actually do is they represent numbers in what's called scientific notation. Scientific notation means a couple of different things. So scientific notation, number one, what's the name for that again? Coefficient, yes. Coefficient is greater than 1, less than 10. So you might be asking, hey, what's the coefficient? Well, the coefficient is this number right here. It's always the number that's going to be at the beginning of whatever it is. Coefficient is the number at the beginning. Number 2, and yes, you should be taking notes on this, the base is always 10. What's the base? Well, it's a big guitar, and oh wait, that's for music class. Sorry. The bass.
You made that sound like you were actually thinking.
What?
You made that sound like you were actually thinking the bass.
You gotta try. The base right there is always 10, and the last part is the exponent is always an integer. Let's go green here. Exponent, which number here would be the exponent?
22.
Yep. Unfortunately not 22, just 23. So that is the exponent. What does integer mean? Oh, they spelled integer way wrong.
Oh, integer. Shoot.
It's something to do with math.
Are the unknowns.
Are they, what is it?
Correct notes.
Man, I'm spelling integer wrong every time here.
It's actually spelled with a Z.
I can't hear you, what?
If I remember right, rational number, not a fraction.
Yeah, what's rational?
Other things.
It's not a fraction, so give me examples of what integers are.
3.
3, what else?
2.
What else?
4.
4, 10, give me other ones.
6.
6, what else?
14.
You guys are just giving me whole numbers, those aren't all integers.
-2.
-2, yes, because integers can be negative, whole numbers are only positive. -14, is 0 count?
No.
Yeah, it counts.
Yes.
Are you gonna use it? Meh, not really. There might be a situation where you use it at some point during the chapter, but for the most part, you don't really need to know that 0
It's like all numbers.
could get to be 1. No, it is all non-fraction or
Yeah, I know,
decimal
like,
numbers.
So 3.2 is not.
3.2 would not work, correct. You cannot have an exponent be a decimal. Again, you should have everything there written, everything on the board written down. So coefficient has to be greater than 1, less than 10, can be a decimal. So it could be 1, 2, 3, 4, 5, 6, 7, 7.3, 8, 9, 9.9, 9.9999999. As soon as it becomes 10, it's out. Cannot be 10. Has to be less than 10. So on page 61, tell whether each of these is correctly written in scientific notation. If it is incorrectly written, state the reason. So a horse has a diameter, a horse chestnut, sorry, I hope a horse doesn't have a diameter of that. Horse chestnut has a diameter of 2 times 10 to the 0th centimeters. Scientific notation or not?
Wait, hold up, say it again.
It's on page 61, example 1. A.
It is not.
2 times 10 to the 0th meters, centimeters. It
I
is.
did it. And I was
Yes,
like,
it is, because it checks all 3 of those boxes. Next one, Neptune is about 4.488 times 10 to the 9th kilometers from the sun. Yes, it is.
4.4, it said 4.4.
4.4. This can be a decimal.
Oh, okay.
This
That was confusing.
cannot. The approximate wavelength of an infrared light is 0.01 times 10 to the negative 5th meters.
No,
Why not?
because you can't have 0.01, it has to be greater, it has to be greater than 1 and less than 10.
What has to be greater than 1 or less than 10?
The coefficient.
Yeah, the coefficient. So if it says 0.01, it's out. A football field, excluding the end zones, is 10 times 10 to the 1 yards long.
No,
Why not?
because it has to be greater than 1 but less than 10.
What has to be greater than 1 but less than 10?
Coefficient.
The coefficient. Yep. Next page, 62. A Brazilian gold frog is 9.6 times 10 to the 0th millimeters long. Page 62. Yes or no? Why, Arlia?
Because the coefficient is less than 10 and the base is 10 and the exponent is an integer.
Yep. Madison, what about the wavelength of green light is about 4.15 times 10 to the negative 7th meters? Yes. Yep, it is. And Emma, number 3, Mars is 0.2244 times 10 to the 7th kilometers from the sun. Nope, why not?
The coefficient is less than 1.
Yep, coefficient doesn't work. Alright, example 2, write each number in scientific notation. They've got 427.7, well, not point y, and then 0.007. So, how do we write these in scientific notation? Well, if you look on there, it basically we want to move the decimal 1, 2 spots. So that makes it 4.277 times 10. This would right here would be times 10 to what power? 427.7 is 427.7 times 10 to what power? Remember, it is times 10 to the, it is times 1. There's no exponent, sorry, there's no base right there.
0.
Times 10 to the 0th, because 10 to the 0th is,
I don't know, but it makes sense.
what is 10 to the 0th?
1.
1, thank you. 10 to the 0th is 1. So, when we move this 1 2 times, this now becomes times 10 to the,
When you move this twice, times the 7.
10 to the what? 7, where are you getting 7? Every time you move it, that's 1/10. Think, 4.277 times 10 means you move it once. Times another 10 means you move it again.
So 2.
Yes. Times 10 to the 2nd power. Every time you move a decimal, that is 1/10, or 1 exponent of 10. What about here? We move it 1, 2, 3 times, because we need it to be between 0 and 10. 7 times 10 to the
1 second. 3rd.
nope.
You moved it 3 times.
I did move it 3 times. Every time you move it means 1 time. Think about it this way, 7 times 10 to the 3rd. Okay, that's 7 times 1,000, right? That means the number is 7,000. Yes, -3. So it depends on which way you move it. If you move it to the left, then it becomes positive. You gotta think about it in terms of what you're actually doing to it. So look at what the number is. Okay, well this is getting bigger. Is it 427.7? Yes, it is. Alright, this one is getting smaller. Is it 7 times 1,000? No, it's not. So that's not gonna work. Alright, well, we got almost done here. Guided practice number 4. Actually, I'm gonna give you guys 60 seconds to do those.
Both of them?
Yeah. 4 and 5, you get 60 seconds to work on. 56 seconds now. Yeah, paper to write on. You got paper to write on? Yeah. Supposed to be taking notes, Ian, supposed to have these. Okay, Madison, pick one. What?
I don't care which one.
Okay. You can do the top one then.
Okay, so, how do you want me to just say it? Do you want me to give the answer? Or
Yeah, give the answer.
8.562 times 10 to the second.
8.562 or 8 and 562 thousandths times 10 to the what?
To the second.
Yep.
And Arlia, second one.
I'm still working on it. I got my stuff on.
Okay, well, I'll give you the first part. It is 6 because you're moving this
Yeah, 6
times 10 to the.
times 10 to the negative first.
If it was negative
No.
first, then you would move it once.
Oh yeah, you moved it twice, so negative second.
Correct. All right. Page 62, bottom of 62, top of 63 actually. Write numbers in standard form. All that means is you're writing like 6.2 times 10 to the, let's see, there's a little caret button on here. Where'd it go? Oh, there it is. 10 to the third power. This right here means that it's to that power. That's what you would do in your calculator. You have to do that. It means that that also equals, it's just saying exactly what it is. So 1, 2, 3 times. Okay, if I write in the 0, it's going to be 6,200. So standard form, standard means regular. That's all it means.
So just the 900.
Yep.
So you just answered the problem that you wrote it in exponential notation. You just answered that.
Yep. So you guys were going from standard form to scientific notation before, and this time you're going scientific notation to standard form. So if it's got, let's go blue here, 7.1 times 10 to the third, well, then you would move this 1, 2, 3 times, fill in the zeros. Okay, that must mean it's 7,100. Pretty simple, right? Or if it's got 8.12 times 10 to the negative third. 1. Okay, well, this time, instead of making it bigger, I'm going to make it smaller because there's a negative decimal point. 1, 2, 3, 0.008, 1, 2. I gotta make it smaller. And if you're not sure whether or not you're making it bigger or smaller, look at this right here. If it's positive, that means you're trying to make the number bigger. If it's negative, that means you're trying to make the number smaller. Yes?
Where'd you get the 1, 2 from?
The book has the example, 8.12. So originally it was this, 8.12 times 10 to the negative third. This decimal point was right here.
Oh,
I
okay,
moved the
yeah.
decimal point three places, and I moved it to the left because I know I'm trying to make the number smaller.
I copied it wrong.
Okay. Alright, guided practice. 9 times 10 to the fourth equals what? What? 9,000. Nope, not 9,000. 10 to the fourth is not 1,000, but 10,000. 10 to the fourth. 9 times 10 to the fourth.
So it's 90,000.
Here's the decimal. Move it bigger. 1, 2, 3, 4.
So it's 90,000.
Yeah, 90,000. And last one, 2.5 times 10 to the negative second is what? Am I moving it to the left or the right?
2.025.
250.
To the left or to the right? Left, because I'm making it left, because I'm making it smaller. 1, 2. That means I have 0.025. And that's it. You can now start on your assignment.